I'd like to hope that with that last example, you guys got a really good sense of all you can do with truth tables and how complicated and beautiful and interesting they can be, but probably what a lot of you guys got from that example is a little bit confused because a lot of T's and F's and a table that you're just now learning what any of the things on there mean. So probably the big thing you learned is that truth tables can be a bit clunky. It takes a lot to get through even a fairly basic case like that last one was. So sometimes when we're doing stuff like using truth tables or using the logic of a truth table, it can be a lot easier to instead think carefully about what the pieces mean and try to arrive at the correct conclusion without going through all the details. Let's take a look at an example here where what we are given is a bar graph on the distribution of attractiveness in the United States, where what we want to do is determine whether the statement "it is not true that 1% of American men are homely and more than half are average," or "it is not true that 5% of American women are strikingly attractive," is true or false. Specific, and I have to wonder where they got those numbers from, but what we're really doing here is trying to pick an option based on truth or falseness using that data set. So first thing we want to do here is set some notation. Just like before, we're going to say that P is 1% of men are homely. I'm going to be a bit quick with how I say that. Q is more than half, so greater than 50% are average. And R is the statement "5% of women," and let me be specific here, that's 50% of men, "are strikingly attractive." Okay, so those are our three pieces there. Let's now, with that notation set, carefully go back through that statement we had to figure out what that would look like symbolically. So our statement was, "It is not true that 1% of American men are homely." So P is 1% are homely. That means we're going to be looking at something involving negating P. Then from there, we have along with more than, excuse me, more than half are average. So when we have the phrase, "it is not true that 1% are homely and more than half are average," what we're saying is we want to take both of these with that negation, and it's sort of spelled out as well with that comma at the end there, because that means we're throwing some parentheses in. And then the last part is, or "it is not true that 5% of women are strikingly attractive." So then we have a disjunction and the negation of the statement "are." As you can imagine, making a truth table for this would be pretty horrible, because you'd have to get that term, you'd have three simple statements, you'd have one negation over here, then another negation over there, then a disjunction of that whole thing. So you would end up with, thinking offhand, 1, 2, 3, 4, 5 columns and 8 rows. It would be quite nasty, and you'd probably lose details working with it. So I think it's for the best that we not. Instead, what we're going to do is look at the information we have to determine whether or not these things are true. Where, based on the data that we have, we can see that P and Q are both true, as we have that 1% of men are homely based on that distribution, and more than 50%, in this case 59%, are average. So since both of these are true, That is, the conjunction is true. The negation of that conjunction is going to be false. That is not P and Q. It is not true that P and Q are is false. Meanwhile, if we look at that graph again, for the statement R, 5% of women are striking, based on the data, it's actually 2%. So, since R is false, the negation of R is true. Remember, if we flip a true statement, we get a false one. And if we flip a false statement, we get a true statement. And as a result, the disjunction negating P and Q, then taking that for the negation of R, is going to be true, because that part there, the negation of R, is true. And all we need for a disjunction to be true is for one piece to be true.